Dr. Henry Borenson created Hands-On Equations. After teaching mathematics for 18 years, he saw a need to make algebra more accessible to students.
I knew that children in 8th and 9th grade were struggling trying to learn algebra as traditionally presented because it's very abstract. So I knew there was a need to develop another method, a simpler method of doing that. And so my task was to see if I could come up with a concrete system that would enable younger children to grasp these ideas.
Hands-On Equations demystifies the learning of algebra.
Let me show you how 4th and 5th graders could begin to do algebraic equations such as this. Okay, those are the 4 blue pawns representing 4 x's.
Any of us who read the research know that anytime you can start with a concrete and then go to pictorial and then go to abstract, that is the best brain-based learning, and that's exactly what this program does.
Now the 2 outside the parentheses means that we double whatever's inside. So we have
Hands-On Equations is not just a game in which students have fun and succeed. They are learning significant algebraic concepts, such as the meaning of an equation, the distributive property, the subtraction property of equality, the addition property of equality, the additive property of zero, the property of additive inverses, and much, much more.
At first, I was a little leery because those of us who have been trained to teach algebra, this was not the ordinary way to teach algebra.
It's been so wonderful that someone actually took their time and developed this so that the kids that I'm teaching are able to learn their algebra in a fun, hands-on way.
It now has become an absolute part of my total algebra program. I introduce algebra with this kid. I wouldn't do it any other way.
Hands-On Equations utilizes the power of whole brain learning.
I think the most valuable thing is it gives kids a visual of what those algebraic ideas are. Kids, you'll see a light go off in their heads. They understand it, they can see it and touch it and manipulate it, which makes it a lot easier.
My classroom is a full inclusion classroom. By working with each other and helping each other, those who don't get it could get help from those who do.
Because like if you get it wrong, then they'll show you what you did wrong and then how to fix it. And if they did it wrong, you could help them.
Oftentimes I find some of my children who have some identified learning disabilities do a lot better with this because their hands are on it, they can move it, they can manipulate it, and it makes sense to them. If they make a mistake, they're willing to go back, try it again.
It won't work.
It won't work. So start over, set it up. It's kind of like they get a do-over and there's no problem because they can just reset up that equation, try it again, see where they made their mistake. And we get a lot of those, Oprah calls them those aha moments, and I'll hear that with kids. Oh, that's where I made my mistake.
All right,
and so it just doesn't threaten them in the way so many things do.
Once you get to algebra, that's when you really want to start moving to more of the abstract. But if they have not had it in elementary school through middle school, then they'll have a difficult time going to the abstract in algebra.
To help teachers use the Hands-On Equations materials in their classrooms, workshops are offered around the country.
That if I take one blue pawn from this side and one blue pawn from this side, my scale is still balanced. Would you agree with that?
So we look over here and we think we can subtract 2 from this side and 2 from this side.
In these workshops, teachers get a chance to master the Hands-On Equations approach.
Increased by 10, 11, 13, 14.
The star can be positive or negative as well, but it's the opposite of x. And guess what they make when they're together? 0.
I enjoyed it because it was concrete, which was really the premise of why we came, to have materials that kids could actually manipulate, especially special ed students that I teach. It just kind of makes it more real for them.
I would say that I think this program will allow every student to be able to participate and actually solve equations, and there are students that may not be successful otherwise, so I think that would be the most powerful part.
21, 21, blackjack.
Yay, give him a hand.
Over the last 2 years, hands-on equations effectiveness has been studied in 17 states, 155 classrooms with over 2,800 students, including LD, ESL, and inner-city students. Dr. Barber has seen firsthand how this program affects student learning.
And I call it the light bulb effect, where all of a sudden you realize they went this, aha, I know what this is, and switched from being non-participants to being in control of their own learning. We have studied children at 3rd grade through the 8th grade. We've studied children who are considered special education. We've studied children who are extremely high functional. In those 155 studies, the vast majority of them, 95% of them or more, show statistically significant gains between the pretest and the post-test.
Here are some recent research results for grade 4 students in Broward County, Florida. The numbers in column A show the percentage of 4th graders who had the example correct on the pretest. The numbers in column B show the percentage of students who had a similar example correct on a retention test administered 3 weeks after the completion of the first 7 lessons of hands-on equations. The students did not use the game pieces on the retention test. Hands-on equations also enhances student self-esteem.
It is amazing with my kids. My lower level kids pop right into it. That's when they first feel success with math.
Oh, it's wonderful. The kids are developing a lot of self-esteem with this program, and it's great to see them feel so successful at something.
And hands-on equations provide students with a solid foundation in basic algebra.
Algebra is a gateway to higher level math. It's a gateway to also to college. So by having students be able to understand how to solve multi-step equations and also solving equations on both sides, then that will allow them to have more confidence going into the higher level maths.
There are many ways to solve this problem. Let's start out by eliminating the green 6.
By understanding the processes of algebra, students gain the mathematical power that increases their interest in learning math.
Now, we can remove this red and green 6 because together they have a 0 weight.
10 and a 9 equals 19. Okay.
So, I think the thing that I like best about it is the fact that it appeals to probably 99.9% of all of the kids that I teach.
Why do you think it's cool? Why do you think it's cool?
Well, because it's okay and it's fun and it just makes you happy.
It makes you happy.
Before it was kind of boring to learn stuff, but now he taught us how to understand it a different way and to make it a fun way to learn.
Everyone should give it a try. It opens the door for kids who can't understand it on a piece of paper. They can manipulate the pieces and actually see how it works.
You get to work with it with your hands and not write it down and stuff. And it's more easier if you see it in person than look at it on a piece of paper.
Hey guys, what do you think of hands-on equations?
We love hands-on equations!